Hello everyone. So in this follow-up video, I'm going to show you how to process the downloaded DTM and DSMs from WebODM to compute Canopy height model for two dates and also find the crop height growth over this 1 month. Please keep in mind that this dataset is a reduced dataset which might have affected the accuracy of the computed crop heights or canopy height models. For more accurate results, you have to process the raw data as such. That means you need more images with more overlap and with more GCP points. For demonstration, let us see how we can compute or how we can process these DTMs and DSMs to get valuable information about crop heights. Once you have downloaded the DTM and DSM from WebODM as GeoTIFF, please open QGIS, and in this case I'm opening QGIS 3.18. The most important thing to note is that open QGIS with grass. Even if you are using a QGIS which is a previous version of 3.18, all these steps should work, but make sure that your QGIS is a recent version released. But what is important here is to make sure that you open QGIS with grass, because we are going to use some of the grass modules integrated with QGIS to compute some relevant statistics. So here I'm opening QGIS. Once the QGIS is opened, let's open a empty project, and in the empty project I'm going to open the 4 raster data sets downloaded from WebODM, which represents 2 DSMs and 2 DTMs. So I'm going to open 4 of them together. You can see that there are 2 DTMs representing 2 dates and 2 DSMs representing 2 dates. I'm also going to open the maize field boundary so that we can clip all our raster files into this boundary. So this is the boundary. I'm going to change the style of this boundary so that we can have a transparent fill. I will give a bright color. So this is the boundary. Let me also increase the thickness of the stroke. So I have 4 raster files and 1 boundary. The first step is, as you saw in the steps, to clip the 2 DTMs and DSMs to the maize field boundary. And then we will have a quick look at the histograms. Let's go back to QGIS and do the clip to boundary. What you can do is you can go to the processing toolbox, search for clip, and then you can see a module called clip raster by mask layer. I will open that module. We'll select the input layer as one of the raster, which is DSM 18 December. Select the mask layer as maize plot. You can leave rest of the options as default, and in the clipped or in the output file name, I will save to file and give a name which is DSM 18 December 2019 underscore clip. So I'll keep the same name with the underscore clip as a suffix. In my case, it's already exists, so I'm rewriting it, and then I will run it to get the clipped DSM for 18th December 2019. Similarly, you continue this step for all the other three raster files. Once you are done with the clipping, you can see, or you will have 4 clipped raster files, which are the clipped ones of 2 DTMs and 2 DSMs from 2 dates. Meantime, I will remove the other 4 raster files to make it light. And without forgetting, I will save the project also. I will give it a name, CHM. So now we have all the clipped DTMs and DSMs. The next step is to, of course, we can check the histograms and also to compute CHM, canopy height model for each date for 22nd Jan and 18th December. And what is CHM? CHM is DSM of one date minus DTM of the same date. So let's do that. So to compute CHM of 18th December, I will subtract DTM 18th December from DSM. So I will go to raster calculator. I will type in DSM 18th December minus DTM 18th December, which will give me CHM, canopy height model 18th December. I will save it. So I have the CHM for the first date. And similarly, I will compute the CHM for the next date, which is DSM 22nd January minus DTM 22nd January, and I will name it as CHM 22nd. So I can select one of these so that I don't have to edit everything. CHM 22nd January 2020. Say OK, and that's also computed. So we have 2 CHMs ready. Now, in the meantime, you can also check, for example, to check the histogram. You already know that. You can go, for example, to check the histogram of DTM at 22nd January. I will go to the properties, histogram, compute histogram, and you can see how the height is distributed over the field. Now you can also check the CHM of 22nd January, which is supposed to be higher because there are more vegetation growth by January. So let's have a quick look at the histogram. We can see that it's very close to 0, and there are few pixels which varies from 0 to, let's say, 0.1. So that means 0 to 10 centimeter, which looks like very low values, which could be the accuracy issues from the drone. As I mentioned earlier, we are using a very reduced data set, which is only 24 images from the drone in comparison to hundreds of images. So that could be the reason why this is of low accuracy. But for demonstration purpose, this is fine, and you will learn how to do this processing, which is the main target of this training. So you have the 2 canopy height model representing 2 different dates of the crop growth. Now the next step is to subtract CHM 18th December from CHM 22nd January to get the crop height, how much height the crop has gained over this period. Yeah. So to do that, I will again go to raster calculator. I will calculate CHM 22nd January minus CHM 18th December, and I will give it a name, crop height from December to Jan. So theoretically, it should give the the height the crops gained over this period. And we can again have a look at the histogram to see how it varies. Again, it's very low values. Most of the vegetated area is up from 0 to 10 centimeter. There are some minus values which should be representing non-vegetated areas. Okay, so that is crop height determination from DTM and DSM. You can also give a different symbology. You can select pseudo color, classify, and see how it looks. But as we have a big tree here and rest of the canopy or rest of the canopies are very low in height, the color scheme will look almost homogeneous here. But this tree is really evident from the crop height map. Now, it would be very useful to get valuable statistics for the crop height. So to get that, I recommend you to use something called r.univar, which computes the univariate statistics. You can open r.univar. You can select crop height, and you can do r.univar for any of these raster maps if you are interested. And in the field separator, I will type comma. And here I'm also interested to get some extended statistics like percentiles. I want to know on the higher side of the distribution, what are the crop height values. For example, I would like to know the crop height at 90 percentile, 95 percentile, and 99 percentile. So this module can also compute values at different percentiles, and I will save it into something called crop height stats.txt and run it. Now what is saved is a comma delimited file. To open that file, I will open Excel. I'll open a blank sheet and go to this particular folder. I will select all files. I'll go to my project folder and select that particular file. Then it will ask for what kind of file, what kind of delimited you have to use. It is comma, next, finish. Now you get a lot of statistics of a crop height, and you can see that the minimum is -2, maximum is 2.5, which corresponds to that big tree. The mean is very low, which I think is due to the fact that there are many non-vegetated or exposed soil there, which was very evident from the vegetation in this map as well. Median is 0, which means the 50% of the at the 50% of the distribution it is 0. So that is why these statistics are very important and may give you some relevant information. Third quartile means 75 percentile. It's 0.01 meter. Then 90 percentile on the higher side. We can see that it goes to 0.02 to 0.06. So these are the stats. I would like to repeat again that the accuracy of these stats depends upon the accuracy of the drawn images, and for project related or for serious processing, you may have to consider processing drawn images with a larger overlap and larger density. Okay, so that's how you will calculate statistics for crop height using QGIS. Hope you understood how you can process these kind of data sets in QGIS and get valuable information. Thank you.